All right, so we've solved problems for arithmetic sequences. We know what our generic formula for these sequences is. U of n equals U of 1, so this would be as the nth term, and this is the first term, plus n minus 1 times d, or our difference. Okay? And for this particular problem, we're solving to find out what our formula is. And we're given U of 11 equals negative 40, and U of 35 equals negative 160. So we know our 11th term is negative 40, our 35th term is negative 160. Okay? Now, our first step is to substitute our knowns into our formula. Okay? So I originally had U of 11. I scratched that out just to make this negative 40. Okay, equals U of 1, because we don't know that. That's an unknown still. Plus, it's our 11th term, so n minus 1 is 10, times d. And we're solving that for d, because that's what the two are going to have in common. Okay, we need to know that next. So we're going to simplify and solve for d. So let's subtract U of 1 from both sides. So now we're going to have negative 40 minus U of 1 equals 10d. And we're going to divide both sides by 10. So we'll wind up with d equals negative 40 minus U of 1 divided by 10. We do the same thing over here, except with U of 35 is negative 160. So negative 160, that was U of 35, but I rewrote it, negative 160 equals U of 1 plus n minus 1 is 34 times d. Again, we simplify and solve. Negative 160, we're going to subtract U of 1 from both sides, so minus U of 1. Okay. So negative 160 minus U of 1 equals 34d. We're going to divide both sides by 34. So d of this side of the equation, negative 160 minus U of 1 over 34. Now, just like in previous problems, when we have d and we know that they're the same, we can set them equal to each other. So that's exactly what we're going to do. Okay? Negative 40 minus U of 1 over 10 equals negative 160 minus U of 1 over 34. Okay, now I went ahead and combined steps because I wrote large and I knew I was going to run out of paper. So I did two steps in one because we need to both multiply both sides by both denominators. So I multiplied both sides by 10 and by 34. Okay, on this side, the 34s are going to cancel out. So while you can go ahead and multiply by those, it's going to wind up adding another step because then you'd have to divide by that same number. Okay, so the 34s cancel out on this side. And the same things with the 10 on this side. So what you really wind up with is 34 times negative 40 minus U of 1 equals 160 minus U of 1 times 10. Okay, that's going to give you negative 1,360 minus 34 U of 1 equals negative 1,600 minus 10 U of 1. Okay, 34 times negative 40 is this. 10 times negative 160 is this. Now we're going to add 1,600. I'm going to say the short version of those longer numbers. We're going to add 1,600 to both sides. That will give us 240 minus 34 U of 1 equals negative 10 U of 1. Now we're going to add 34 U of 1 to both sides. And we're going to get 240 equals 24 U of 1. Now to find the U of 1, our first term. We're going to divide both sides by 24. Okay, so u of 1 is going to equal 10. Now, we're going to go back and plug that into one of our two equations that we found in the first steps of this problem. I chose the left equation because it's smaller numbers, and if I'm having to plug something back in and I'm almost done with a problem, I personally want to do the least number of steps possible. So I chose to plug our u of 1 into d equals negative 40 minus u of 1 over 10. So that becomes d equals negative 40 minus 10 over 10. When you combine these two numbers, that gives you a negative 50. So d equals negative 50 divided by 10. So our d, our difference between each of the given terms in this arithmetic sequence, is negative 5. Now, we know our d, we know our first term. So we can go back and write our formula. And just for memory's sake, I rewrote it down here. U of n equals u of the first term plus n minus 1 times d. So that is going to be u of n equals 10 plus n minus 1 times negative 5.